Awesome. Well, thank you, Karim and Lachlan, for the opportunity today to present this. My name is Jesse Loudon. I am a principal consultant at Lab 3, coming to you live from Sydney, Australia. It is a bit chilly here, so forgive me if I let out some coughs. I'm not sick at all. Just been nursing a cough for the past couple of weeks. So today's session is it is dry coding with Terraform CSVs ForEach. I'm pretty passionate about this. I've been using it, this sort of pattern for the past few months, actually. Myself, I've been working with Terraform for about 1 year only. So I'm still a bit of a baby in terms of Terraform expertise. And yeah, I'm really passionate about Microsoft Azure as well. So if you follow me on any social media, you'll notice I'm doing a lot on the sort of Microsoft Azure space. So let's kick on. Initially, when I was coming up with these slides, I kind of wanted to start with, a background of why we do something. So to give you some insights here, the problems that I was solving when I was working on this pattern and looking into if this would work for me, I had a very large problem, and that problem was, well, there was actually multiple problems. I had a lot of data, so I had large scale inputs that I needed to provision into Microsoft Azure. There would be frequent changes to this data, so a lot of adds, updates over time. I wanted to maximize code reusability, and the reason for that is because I've done very opinionated Terraform modules and environments before, and I found that the reusability of those environments was minimal. So I really wanted to start with a vision in mind this time around to maximize my reusability for this Terraform code and for this environment. And I also wanted to minimize coding effort. I don't have a lot of time to spend working on Terraform modules and whatnot. So I wanted to take the learnings from past experience and code that had already been used and built and tested by other people. So, it's also very time sensitive in terms of, what you're doing. We often don't start with a lot of time budget for working with these kind of, projects in mind, if I could say that. So this image here, I think a lot of us can relate to. It's kind of been going around recently. I think it is a good segue into what we're talking about today, how Terraform, the CSV decode function and the ForEach metadata, the meta argument exactly, can be used to move and unblock your problem, which is large amounts of data. And in this case, I'm going to use CSV to handle that. In your specific use cases, you may look at using perhaps YAML files or JSON or some other sort of data type. So let's kick on here. Now I want to talk initially about the data. I think this is a good point to start with because, when you have a goal in mind, you don't often start with, oh, I have this Terraform code or this module or this pattern, and I want to look for data to use it with. Often we start with, we have some requirements, so we need to build something. And that means you have some initial data already gathered in terms of what you want to build, right? And then you go start looking at, how do I build that quickly? How do I make the code reusable and as dry as possible? So let's start with the data. Here is an example data set, nicely formatted for easier viewing in this slide. This is a CSV data set. You may not be able to notice because of the sort of table format here, but essentially the basic layout here is that there's a header row, which is that top row there. And each of these values in the header row, so region here on the left column, this is going to be the key for our key value pairs. So region will map to Australia Southeast, Australia East, New Zealand North. New Zealand North doesn't exist yet, but it is coming soon. So I'm kind of like, future planning here for when that region is available. Hopefully this slide stands the test of time. Now RG name, that's resource group name. So you can see this is a data set for provisioning resource groups into Azure. And basically, each new line under the header row at the top, represents a new resource in your deployment. So I just want to show this to you to start off with, to kind of set the scene for what's going to come. Now, under the hood, CSV decode as a function, what it's doing is essentially it's taking our CSV rows, the values from the rows, which are comma separated values, and it's converting them into a single list containing multiple maps. So you can see here on the right is the native CSV type data. Not pretty or anything, but it is, I guess, digestible for this slide. So on the left is what you get as an output when you run CSV decode using that data. So you can see how it organizes the data into maps. And this is important to understand because when you're working with CSV decode, you may need to understand how this all works under the hood in terms of troubleshooting why your data is not coming through properly or why resources are not being provisioned as you would expect. So I think this is a good introduction to that. Now, alone by itself, each of these kind of tools, CSV decode and ForEach, they can be used independently of each other. When I was researching this solution, I actually came across the idea from one of my ex-work colleagues, and I'll link the blog to you later on in this presentation. But really, and this is something I discovered myself after finding that blog, CSV decode and ForEach, they're kind of like a really good pair. They're better together. HashiCorp Terraform have documentation to back this up where it actually gives you patterns and examples on using both of these together. So that was a really good help for me when I was learning how this would work and kind of finding out, whether this was feasible for my use case. So let's look at an example, some code here, some snippet, just simplified for this session. On the top here, we've got a local variable called RG for resource group. This is using the CSV decode function. It's calling a CSV file, which lives in my repository locally. And then the second line below that is actually a module for a resource group, also in my local repository. And it's calling that local variable for RG and basically ingesting it in the format that you saw on the previous slide, where it's a list of maps. Now, you may notice this ForEach expression here. It is doing something other than just referencing the local variable. So if you look at where it shows here, rg.rg name, this is important to note because this actually assigns a unique ID column for your maps that come in through CSV, and that unique ID column is important to assign for your data sets coming in, because as you make changes to that CSV file, maybe you're adding resources, removing resources. If you don't have this unique ID column set as you bring in the data to your resource or your module, it can make it very difficult and very troublesome to actually make changes through Terraform. And I'll give you a demonstration of this as I go along. So you can see here name and location, the different variables being passed into the module here for resource group. They're referencing in each value. So this actually is the each value.rg name. This is a reference to the column name that you saw on the previous slide. So you do need to make sure as part of your CSV design, your column names, I think, should be consistent. They should have a naming convention. And it also makes it easier when you're designing and maintaining these modules and resources that are using ForEach based on your CSV inputs, right? So this is kind of like an introduction to how you would go about implementing this from a very simplistic point of view. Now let's talk about how we can use this pattern for the don't repeat yourself methodology. And the example I have here on the screen is, so let's say we have a CSV data set for resource groups or virtual machines. We can call that same CSV data set from multiple modules and resources within our code. And that way we maximize the reusability of the data set. And we're not having to recreate the same amounts of data or code. And it's all minimized and as dry as possible. So let me go to the next slide here. There's a bit more going on this slide, so I apologize for that, but I really tried to condense this down into something which provides the most value for this presentation. So at the top here, in the local variable, I've changed resource group to VM just to show you that we're now pulling in data for a number of virtual machines. And on the right, you can see an example of that data in a nice table format. So what this would do is it actually creates virtual machines. So below that local variable definition, we have a module for a virtual machine. This will be a Windows virtual machine, I think. Notice that it has a depends on statement there, and it will reference a resource group module, which I showed in a previous slide. This is something I found that I needed to do because I'm using CSV data sets and there's no implicit dependency for your resources. So, your data set has a resource group name there that you can see on the right and a virtual machine name, but because it's coming from CSV, Terraform does not create these implicit dependencies between them. So, if I didn't have the resource groups created ahead of time before the virtual machines, sometimes my Terraform deployments would fail. So some notes from the field here. This depends on argument here that I put in. It's very important if you're using this pattern, just to ensure that the underlying required resources are created in the right order. So you can see here again, we got a ForEach referencing that local VM variable. I'm assigning the unique ID for this ForEach module to the VM name, and that's important. I don't think you'll have the same virtual machine names in your environment. It's very unlikely. So that's what I've chosen. Now you can see these purple arrows here that I put in are just an example of where we can leverage a dry methodology, a dry pattern for using CSVs and ForEach. So we've got resource group name here. We've got virtual machine name in this column. And both of these values for this particular resource is going to be used multiple times across multiple modules or resources. And the second resource that will use those values is actually for a backup. So this is just an example that I've used in the past. I've created a virtual machine. I've also created a backup object in Azure for that virtual machine, and I've referenced the same data set. So I didn't have to create a new data set containing all the resource group names and virtual machine names and backup policy IDs and all that in a different data set, which I would have to manage. So I've used that same data set here. And what you can see in the source VM ID, I just want to call this out as well. I'm using an expression here. It's kind of like a concatenation string. So it's creating a resource ID using the values from the CSV file. And this is something I've leveraged a number of times to basically keep resource IDs, which can be very, very long. I've used this expression to ensure that the CSV data is as minimal as possible. Because if I had this resource ID defined in my CSV, it would be quite hard to read and manage that. So I've used this concatenation string. I think you should check it out if you're not using that today. It's very useful. So hopefully this gives you an introduction to how we can keep our code and our data as dry as possible. Let's continue on. Lessons learned. So like I said, I've been working on with this kind of pattern for a couple of months, and there's some things that came up repeatedly, and I spent a lot of time kind of troubleshooting and figuring out, why did this break? Why was this issue appearing or something not working? So let me let me show you some mistakes I made and try and help you to avoid those. So notes from the field here on using CSV decode and ForEach. A couple of times I had some spaces within my cells, and CSV decode will see that as, so each cell represents a string in your map. And if you have spaces in your string, what it appears like is this, this representation here. So you can see there's, after the foo, there's some spaces before the string terminates. That represents a problem, especially if your parameters or your arguments for your resource or module does not support spaces. And that's very, very common with using Terraform. So, you know, a lot of times I'd say, why isn't this working? And it's because of spaces. So I'll show you in the demo how you can prevent that from happening and how you can kind of catch that using
I think that wasn't you. I think that was what happens when somebody applies live changes to the Zoom infrastructure while other people are doing a live stream. Apologies for that. Whenever you're ready, feel free to rewind yourself in 30 seconds in your head. We'll fix this in post-production because that's the magic of editing. And sorry about that.
Awesome. So yeah, I'm ready now.
Taylor confirming we're good to go. Awesome. Let's do it. This was the best part as well.
So the empty extra cells point here from you know my learnings using this pattern. Empty cells will happen. Sometimes you'll have a column within your CSV data that needs to be empty, or it just doesn't have a value there. And you can use an expression. So you can use a conditional expression in your Terraform module or resource to accommodate for these empty cells. And I'll show you how that works in the next slide or in my demo as well. Now, following on from that, list values, often you'll have, say, for example, if you're creating a virtual network, you'll have DNS servers coming in as part of your virtual network creation. And in the DNS IPs, you'll have multiple IPs, obviously, I hope. So what that gets seen as is, as you can see on the screen here, it gets seen as comma separated values, but within a single string. Now, when you bring that into your Terraform code, this actually is not an acceptable list because it's a single string. So what we need to do is we need to use the split function within Terraform to actually split up these comma separated values into multiple strings, which can then be passed into your module or your resource. And finally, last but not least, this unique column changes example here. So before, just a few minutes ago, I mentioned that you can assign a unique column to your ForEach module or resource. If you make changes to the value of that unique column, so let's say, you know, my unique column is the virtual machine name. If I made a change to the virtual machine name in that column, it would want to recreate the entire resource. And that's really important to understand that the data in that unique column is pretty sacred. The values are pretty sacred. If you're going to change the values in that column and you don't want to recreate the resource, be prepared to do a Terraform state move, for example. So you can move the resource from in your state file from the previous resource name, which will be tied to that unique column ID. Okay, so that pretty much wraps up the sort of top mistakes that I made, and hopefully, you know, this gives you a kind of heads up in advance of you using this if you're not already doing that. So hopefully we have time as well for a quick demo. Let me just minimize this. So I've got Visual Studio Code here. I have a very small proof of concept that I just created ahead of time, and I've run Terraform Apply ahead of time as well. You see, you're not waiting for me or the resources to be created as part of the session. So on the screen here, you can see I'm creating resource groups. I'm bringing in some local variable here for RG, similar to what I showed you before. I'm using a resource group module. I'm using the ForEach expression here. And the unique ID is the RG name. Again, very, very similar. And I'm outputting the resource group local variable from CSV decode just to show you what it looks like. So I've run that already. And you can see here, similar to what I've shown you before, just highlighting here that this is a list. The CSV decode function brings in a list of maps. So each one of these maps represents an individual resource, sorry, an individual resource in your deployment, right? And each one of these keys here, so RG name, region, that's a column within your CSV file. That's the header column, right? And here's the values. So this is a resource group in Australia Southeast named AUS-HashiTalk 01. And there's other resources as well, all uniquely named, but using the same keys there for definition. Now, what I want to show you as well, here's the CSV file. It's local in my repository. So remember I mentioned the unique ID column. So if let's say I change the order of one of these resources, if I just cut this, I'll move that from line 3 in my CSV, I'll move that to line 13 and I'll save that. And in my terminal, I'll go Terraform Plan. Now what should happen, I've moved one of the resources to a different line. And if you're using that unique ID trick that I showed you, what should happen is Terraform Plan should not be picking up any changes in terms of having to recreate a resource. So I run Terraform Plan. It's saying here 0 to add, 0 to change, 0 to destroy. You'll notice the outputs have changed because I moved that particular resource to a different row within the CSV data. So that's obviously coming down here. Now I'm using the latest version of Terraform in this demonstration. So this is 0.15.0. So nicely, I do like how it only shows, what has changed and it hides what hasn't changed. That's a very nice feature of 0.15. Now let's look at another example here. What if I added a new resource? So I'm going to add a new resource here, Southeast AUS HashiTalks. Let's call this 07 as in terms of a resource name. So I've saved that. What if I had a space in my resource name, or what if I had a space in the region? So I'll add in a space here. Maybe I accidentally did this, or perhaps, perhaps someone else did this, or perhaps some automation did this as part of your data generation. So I've saved that file. If I run Terraform Plan, it most likely will come up with an error because a space within your region name is not going to be accepted by the module or the resource that you are trying to provision, for example, in this case, to Microsoft Azure. So it should come up with an error. There you go. So the error says that the name, so it's actually mentioning the resource group name here, not the region. I'm not sure if it will mention the region later on after I fix the resource group name. But yeah, it does mention like, oh, this can only contain alphanumeric characters, dashes, underscores, that kind of thing. So here's how you can stop this from happening. Within my own terminal Visual Studio Code, I am using an extension called CSV edit CSV. This extension has been pretty useful. It's created open source by a contributor in the community. And what you can do with this, So if you notice in the bottom of my terminal, if I just zoom in here, these options, so I've got an align option here. That's coming in from the edit CSV extension. So what I can do is I can align all my rows to the columns, so it looks nicer, and that makes it easier to edit within my Visual Studio Code window. I can also shrink. So if I click align, it'll change the option to shrink. If I click shrink, it actually removes those spaces that I put in intentionally. And this is a really important point that sometimes you'll be doing edits, lots of edits in your CSV files within Visual Studio Code. And you need to just make sure there's no extra spaces in your cells, which are going to cause issues. So I highly recommend this extension. Use the align or shrink. Shrink will remove any extra spaces. So let's save that. And now if I run Terraform Plan, it should pick up that I have a new resource. That's the 07 resource group in Australia Southeast. And while that's running, let me show you in the portal. So all these resources were created ahead of time. There we go. So if I go back to my terminal now, it's actually finished that plan, and it's picked up that I have a new resource to add. There we go. I'm not going to add that now, but what I will do is I will add a new column and some data for this data set and bring that into my module. So I'm going to do tags. I think this is pretty common. So I'll just remove this commented bit of input here. So I'm going to bring in a tag called CostCode, and I'm going to reference a column using each value. And I'm going to name that column tag CostCode with no spaces. So if I take this in my CSV, again, this is very useful. If I go edit as CSV using the extension, I can add a new column here. I'll name this exactly what I'm using within the code. So tag CostCode. I'll just name this HashiTalks ANZ. How about that? So as I duplicate that down, sorry, this is taking so long, I didn't realize. So that's done. So I've got some values in there. I've got a new tag column, which will come in through csvdecode. I'm going to apply and change that. This is using the edit CSV extension. So I will now look at my raw CSV data here. So you can see my new tag value. I don't believe there's any spaces, so that's good. Now let's do a Terraform plan. And remember, I uncommented the tag input from my module. So this should be picking up that I'm now going to add this tag value from the local variable for resource groups, which uses csvdecode. Now, I don't know if I have time to actually apply this, but let's just see how we go. Okay, so that was pretty quick. So you can see here in my outputs that are coming up, it is going to add the tag CostCode to each of these maps, which represents an individual resource. So let's see if I can quickly approve this. Terraform apply, auto approve. And what we should see as I refresh the portal after this deployment finishes, we should see that tag applied to our resources live within the environment. And sometimes, like I mentioned before, you may have cases where you're going to have empty values for these cells. What you can do is you can do a sort of conditional. Okay, that finished the apply. What you can do is you can do a conditional expression. So you can do an if-then expression for these values. So if the value is empty, apply this value, which might be null, or it might be a string or an object or an array, depending on what is required by your module or resource. Or if it's not empty, use the value that's from the cell, if that makes sense. Okay, so that apply has run. And if I refresh, there we go. So if I zoom in here, you can see my CostCode tag is coming in from my CSV dataset, HashiTalks ANZ on one of these resource groups. And that's pretty much, that's an example of how I very quickly modified my CSV data to bring in a new element of this environment. And I didn't have to do much coding here. I had a very, kind of minimal parameter bringing the value from that new column into my module. And you can repeat this out as many times as you want across different modules, different resources, and alike. So that pretty much wraps up the demo. It's very simplistic. I think we don't have a lot of time to do much more there. Let me kick on to go back to my slides here. Let me kick on to where do we go from here? So if you're not using CSV decode or ForEach today, I do highly recommend you go and test it out yourself and see if it can work for you. Certainly, there are some things I haven't had time to mention in this demonstration and session. So it's very interesting to go and do your own research, do your own testing. I think you'll learn a lot that way. And also, don't repeat yourself strategy. This is kind of like, the ultimate mecca, I think, for anyone who works in infrastructure as code, that we need to kind of have this idea of doing as minimal as possible because of time constraints, because of budget, and because we just don't get a lot of value by repeating the same code or logic in multiple places, if that makes sense. Look for economies of scale with data sets. So you might have a data set for virtual machines. That same data set, for example, can also be used for your backups if you're creating backups for each of your virtual machines. So that's one example where you don't need to spend time creating a new data set and manage those inputs separately to your virtual machine data set, for example. And beware of those data set gotchas. So on the previous slide, I showed you some mistakes I made. Empty cells, spaces in strings, list values not being calculated correctly. And also that planning for changes as part of your implementation and design is very important. I think it's very, very rare that you would deploy once, like infrastructure code, you deploy once and then never have to do a change again. This is going to happen, especially in like an agile sort of environment where you start with a very small design, you kind of rapidly iterate on that design, and you're constantly deploying, looking to add value constantly rather than just doing a huge design up front. You deploy it once after a few months, and then that's it. I think that's very uncommon. So definitely plan for changes to your code, plan for changes to your inputs. Look for that consistency that you can bake into your design and your code. Lastly, I mentioned before when I was researching this solution, I did come across a blog from one of my ex-work colleagues, Lucian. So just linking that here. If you're looking for some inspiration, Lucian's written a pretty cool introduction to how he used the very similar pattern, CSV files, Terraform, CSV decode, and ForEach. In his use case, I think it was adding routes to a virtual network. So check that out if you have time. And that pretty much wraps up my session. Thank you very much, and take care.